This is notes 2.5, solidifying the derivative as a tangent line. Pictured is the graph of g of x, and we're going to use that graph to answer all four of these questions. Number one, find g prime of -4 and explain what the value represents in terms of the graph of the function g. Well, to find g prime of 4, that means we've got to find the derivative of this function here. And at this point, we have not learned how to take a derivative of a composite function. So we need to simplify this so it's in polynomial form. I'm going to take function g, which is 1/2 times the sum of x and 2 squared minus 4. I'm going to multiply this stuff together because it says to square it. And it's going to give me 1/2 times x squared plus 4x plus 4. Bring down the minus 4. If I distribute this 1/2, I'm going to end up with g of x is 1/2 of x squared plus 2x plus 2 minus 4. Then when I combine like terms, I get that g of x is this function. Now, we haven't done anything yet. We've just changed the form of this g so we could find the derivative easily. So find g prime of x. G prime of x, I'm going to use the power rule. 2 times 1/2 is 1. Subtract 1 from the exponent. It's going to give me 1x to the first plus. Derivative of 2x is 2 because this exponent is 1. 1 times 2 is 2. Subtract 1 from the exponent and we get x to the 0. X to the 0 is 1. The derivative of a minus 2 is 0. We're supposed to figure out specifically what's g prime of 4. So if I put a 4 into this, 4 plus 2, pardon me, I'm supposed to evaluate this at g prime of -4. It's -4 plus 2. Therefore, we got g prime of -4 is -2. We're supposed to find g prime of -4. We did that. Explain what this represents in terms of the graph. So this is one of our answers. So what does this represent as part of the graph? We're going to say g prime of 4 equals -2 represents the slope of the tangent line of g of x at x equals -4. You have to include the tangent line of which graph, and you have to say where that's happening. Number 2, find the equation of the tangent line drawn to the graph of g of x at x equals -4. Sketch a graph of this tangent line on the grid above. I'm just going to bring this down here so I can see it. You don't need to redraw this down here. Just want to be able to see it when I'm doing this problem. So in order to make the equation of a tangent line, I need a point of tangency, I need a slope of tangency, and then I can make the tangent line. Point of tangency when x is -4. Well, if we go here to -4, that's hitting the graph here at -4, -2. So the point of tangency is -4, -2. Just looking at the graph for that. There's nothing else we need to do for it. Find the slope of tangency. Well, we just found that out in this previous problem. The slope, g prime of -4, that's equal to -2. To make the equation of the tangent line, we're going to use point slope form, which is y minus y sub 1. Our y sub 1 is -2, so we have y plus 2 equals the slope, -2, times the difference of x and x sub 1. So that would be x minus the -4, which is x plus 4. This is the tangent line. Sketch a graph of this tangent line. We take the slope of we take the point of tangency, which is -4, -2. Then we use the slope -2 to find other points. So from here we go down 2 and to the right 1. We can go up 2 and to the left 1. So use your straight edge to connect these points. So this is our tangent line. All right, go on to question 3. Using the equation of the tangent line, so I'm just going to copy that down. Using the equation of the tangent line, find the value of y when x is negative 3.9. Then find the value of g of negative 3.9. Well, that's two different things. So using the equation of the tangent line to find that, then we got to also find this value. So those are two separate things. I think that you would agree that negative 3.9 is super close to negative 4. We use this equation, we use this point of tangency, negative 4, to find this tangent line. So just looking at this to give you an idea of what's happening, this tangent line would be a good representation of what the graph would be at negative 3.9, which is right here. The y value on this curve would be pretty close to the y value on this tangent line. So we are going to use, it tells us exactly what to do. Using the equation of the tangent line right here, find the value of y. So we're supposed to solve this equation for y when x is negative 3.9. So let's do that. Negative 3.9 plus 4 is 0.1. Negative 2 times 0.1 is negative 0.2. If you subtract 2 from both sides, you're going to get negative 2.2. Keep in mind, this here is all an approximation. It says find the value of y when x is negative 3.9. This is an approximation of what the actual value would be on the function. Then you're supposed to find the value of g of negative 3.9. So let's use the function. G of x is 1/2 times the sum of x and 2 squared minus 4. So we're going to have negative 3.9 plus 2. If you add those together, we're going to get 1/2 times negative 1.9 squared minus 4. If you put this into your calculator, which is what I'm going to do now, I'm going to get negative 2.195. I'd like to point something out. These are calculations that we could do pretty easily with our brain. This calculation here starts to get pretty cumbersome with your brain. We'll come back to this in a moment. We've answered the two questions. This is the tangent line evaluated at negative 3.9, and this is the function evaluated at negative 3.9. I'm just going to pull these down a little bit so I can see these when I answer this next question. Next question, what do you notice about the values of these two results from number 3? What does this imply about how the equation of the tangent line might be used? Well, here's what I would say. The two results from question 3 are very close in value. To each other. What does that imply? Well, here's what it implies. This implies, and this is the reason that we even did this problem. We did problem number 3. This implies the equation of the tangent line can be used to approximate a value of the function close to the point of tangency. Now, this is not some obscure thing. This is going to be used on the AP Calculus test. What's in this box? Super important. One of my students that I had last year missed this question every time we had to apply this on a test. Missed it every time. And yet he overcame that and still got a 5 on the test. So whatever that means to you. So that finishes this first example, 1 graph, 4 questions. I will stop this video here and we will do a video on the next graph and answer some questions for it.